Supercomputers. So what is a supercomputer anyway? Well, it's a computer that leads all others in processing power and speed. Supercomputers are used for weather prediction, jet design, space and medical research, the study of evolution, simulating earthquakes, and a whole lot more. And at the San Diego Supercomputer Center, located on the campus of the University of California at San Diego, supercomputers are used by scientists, engineers, and researchers who need extreme computing capabilities and data storage.
Our supercomputers are among the most powerful supercomputers at academic sites in the world, and we serve a large community, including the user community from the National Science Foundation.
One of SDSC's supercomputers is called DataStar, and it clocks in at 15 teraflops. The other is an IBM Blue Gene called Intimidator, and it boasts a whopping 17 teraflops.
A teraflop is 1 trillion calculations per second, and you can think of your laptop as roughly about 1 billion calculations per second. So our supercomputers are about 15, perhaps 17,000 times more powerful than your laptop. One of the most exciting applications that we've done on our supercomputers is simulation of seismic activity in the Los Angeles basin, a great application called Terashake.
Terashake is a large earthquake simulation. It's a very clever name. Tera means large, implies 10 to the power 12. Shake is a reference to an earthquake. Terashake is a simulation which uses Terascale resources. The Terashake region covers a densely populated area in Southern California, including Los Angeles, San Diego, Riverside, and some parts of Mexico.
And it took the work of 33 scientists, SDSC supercomputers, and 8 institutions like the Southern California Earthquake Center and the National Science Foundation to make Terashake a reality.
Terashake does not really predict earthquake in the sense it doesn't predict when it's going to happen, but it does try to predict what's going to happen.
These large-scale virtual earthquake simulations give a never-before-seen view of how earthquake waves spread across a vast area of California, allowing scientists to connect the dots and understand what's really going on.
From the visualizations done at the center, the scientists were able to find out some important characteristic of the simulation, which is when the fault ruptures, it doesn't move all the way north on the San Andreas Fault, but it makes a turn towards Los Angeles.
The findings of these simulations indicate that there'll be a large, long-lasting shaking in the Los Angeles area, causing the entire basin to jiggle like a plate of Jell-O.
The Terashake platform is moving towards simulating the earthquakes at a much higher resolution. This would also require a lot more computing power. This is where our center is heading, towards petascale computing.
Petascale takes us to another level entirely. It's going to allow scientists to work at a new resolution. If you're doing 2D simulations now, it allows you to do 3D simulations. And it allows us to understand phenomenon that we wouldn't in the small scale. So Petascale is coming, and we're really excited and on top of that here.
With petascale computing, scientists can learn far more about seismic activity and maybe someday even predict an earthquake. But until then, Terashake will continue to provide simulations so scientists and engineers can learn more, design safer structures, and potentially save lives.